Right, so the past 2 days basically we've been adding and subtracting. Yesterday we talked about subtracting polynomials, which basically if we had f of x minus g of x, the only difference is, so like say f of x is minus 1, x minus 1, g of x is 2x plus 7. We have to subtract the entire right hand side, so you need to distribute that negative. And then combine your terms, okay? But that's the only thing that we added new yesterday. So today we're going to be multiplying these things, which we already know how to multiply binomials, but we're still going to go over a little bit, make sure we're on the same page. We'll start with a couple word problems, all right? Because that's what gives people the most problems. So Kelly owns a picture framing company. One of the services she provides is to set the picture in a 3-inch mat, similar to the diagram below, where X is the width of the picture being matted. Anybody here know what a picture mat is? All right, you ever seen a really nice photo and they have that border around it, solid color border? That border is called a mat or a matting. All right, whether it's a photo or like a piece of artwork, that sort of thing, that's called matting, is what's around it. All right. So here we go. They want to write two functions. One with W to represent the width of the matting. So here we go. Come on. So W of x we're going to make equal to the width. Well, the width is not just the x right here. We want the whole thing. So how much do we have extra on the left and the right? How much we have to add over here? Well, what's that width right there? 3. Says it right there. There's a 3 inches on the left. Okay. How many inches are there on the right? How many inches are over here? Still 3. It's 3 inches all the way around. So that would be x what? Plus 3, plus 6, plus 9, minus 6, minus 9, what? Are we adding the 3's? Are we subtracting the 3's? If I want this whole distance, I'm doing x. What am I doing here? Am I adding something? Am I subtracting something? Am I multiplying by something? You're adding it. So it would be x plus what? Well, it's 3 on the right and 3 on the left. So it's what? 6. The width is x plus 6. It's that middle plus 3 on either side. All right? So here we go. So the width equals x plus 6. Cool? I'm going to erase all this. Anybody struggling with that still? All right, cool. They say write a function, and they want to say h of x, where h is the height of the mat. So h of x is this distance right here, which is x plus 7. All right, but it's not just the x plus 7. What else is it? Plus 6, because I got 3 on top and I got 3 on bottom. So what's 7 plus 6? 13. So h of x is x plus 13. Cool? Any problems with how we found that? Any of those? All right, here we go. Write a function a of x to represent the area of the mat needed before cutting a hole. So we're not talking about just the area, we're talking about the entire area of that outside. How do you find the area of a rectangle? Length times width. It is one side times the other side. So the area equals, that's a of x equals w of x times h of x. It's the width times the height. Here we go. What was the width? X plus 6. What was the height? I'll pause. Anybody struggling with that at all? How we got that? What for? Why? We just know it's base times height, so it's one side times the other side. So all we got to do now is multiply it out. So here we're going to go. We'll go over to the right. X plus 6 times x plus 13. What's 13 times 6? Anybody know? What's 10 times 6? 60. What's 3 times 6? 18. Good. So what's 60 plus 18? 78. What's 13 times x? 13x. All right, move over to the x. What's x times 6? And what is x times x? Good. So we got x squared plus how many x's in the middle? 19 plus 78. So let's scroll back over. The area of x. The area of it will equal x squared plus 19x plus 78. Cool? Yeah, you got that? Actually. All right. Thank you. So, any questions on this so far? Anybody got a problem? All right, so what type of functions are W and H? It says what type of functions are WH? They want to know what kind of function are these two right here? Are they lines? Are they quadratics? Are they cubics? They're lines. They're just x's, so they're linear. Okay? Then it says what type of function is a of x? So after I multiplied those two linears together, the result was a what? A quadratic, an x squared. So these type of questions, which will show up on your homework, are just asking what kind of formula is this? Is it a line, an x? Is it a quadratic, an x squared? A cubic, an x to the third? A quartic, an x to the fourth? I don't think it goes up to quartic, but whatever. All right? And that's it. All right, the last type of question asked. The very last question says, what is the area of the matting needed for a 9-inch picture? What is the area needed for a 9-inch picture? Okay, so which of the three functions represents area? W, H, or A? A. So we want to know A of 9, because it's a 9-inch picture. So plug in 9. We got 9 squared plus, what is it, 19 times 9? Plus, I think it's 78 up there. Yeah. So that's what, 81 plus, I don't know, 171 plus 78? It's 300 something, I don't know. What do you get? Just stick this thing in your calculator. I'm sorry, I wasn't very clear on that. You can literally just type 9 squared plus 19 times 9 plus 78, hit enter. I think it's like 340 or 320 or something like that, if I remember. I might be way off. Huh? 230? 330. Oh, 330? Okay. I was close. So 330 square inches, so inches squared. If you're adding your units to it. Cool. How are we doing this? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3, 2, I'm lost. 1, help. Sweet. All right, turn the page. It's the same type of thing. All right, but it just asked from a different direction. A labeling manufacturer wants to start making labels to go around different size cans. They will use the radius of the can to determine the size of the label. So if I'm going to zoom in on this real quick. Basically, this is a stretched out can over here. So like the circle is the top and the rectangle is the label that goes around it. Okay? So the circumference right here is the length or the width of the label. Does that make sense? That's how this picture works. All right? So here we go. They say, write an equation f of x to represent the width of the label. So this width right here is the same as the circumference. Anybody remember the equation for the circumference of a circle?
Yeah, radius is R2 multiplied by 3.14.
Good. So the circumference is 2 times pi times r. which we'll just leave it as pi. We're not going to turn it to 3.14. Just leave it alone. So f of x equals 2 pi. And what's your radius? X. That's our unknown. Cool? It says write an equation g of x to represent the height of the label. The height right here. Well, what's the height? X plus 3. Just got it straight off of there. All right? Last but not least, it says write an equation h of x to represent the area of the label. Well, what shape is the area? Square or rectangle. It's a quadrilateral if you want to be specific. How do you find the area of that? Multiply length times width. So multiply your length and your width. So h of x equals, well, one of them times, not minus, times the other. So we've got 2 pi x times x plus 3. Cool? So here's what I'm going to do with this. I'm going to leave the pi out front. To clean this up, I'm going to leave the pi out front because I don't want to multiply by 3.14. And I'm going to distribute the 2 and the x. Okay, so like 2 times 1 is what? 2. X times x is x squared. Okay, move over to the 3. 2 times 3 is, and x times, well, no x is still an x. So that's how we're going to leave it. All right? Still in terms of pi. Now, if you distributed the pi as well, you would just have 2 pi x squared plus 6 pi x. And that's fine. All right, I just left it up front. All right, last but not least, and that's really just kind of a style choice more than anything else. But if a can has a radius of 7, what would the area of its label be? Okay, so they want to know the area. Well, which function represents area? F, G, or H? H. So H, what number are we plugging in? 7 equals pi times 2 times 7 squared plus 6 times 7. And you can plug that side right there into your calculator. So what's 2 times 7 squared plus 6 times 7? That's what, 49, 80, I think it's 140. Is it 140? 140? All right, cool. So that's 140 pi. That would be the area if the radius was 7. And you just leave it. This is what we mean by in terms of pi. Okay, you got that little bit in geometry. In terms of pi means don't multiply the pi. Treat it like a variable. Just move it around with everything. Cool. That's all they mean. Cool. And I'm not going to do the last two. But do we have any questions on this at all? All right, let's do one more. Let's do one more. Okay. Actually, 2 more. These types, so that's one type. They're going to give you a situation to say, get the dimensions of it. And since this section is over multiplying, you're probably going to have to multiply them. Just giving you a heads up if you hadn't figured that out already. Sorry, that was really sarcastic, but anyways. So here we go. F of x times g of x. All right, that's what h of x is. So to find h of x, I got x minus 3 squared. So I'm just going to go x minus 3 times x minus 3. Oh, stop it. Projection was stopped because stream mirror is on. What? X minus 3. What is that? Canvas? I've never even heard of that. Close that. I don't even know what that program is. Connected with app. Let's try this again. Stop. Start. Don't you love technology? There it goes. All right, so we say we got x minus 3 times x minus 3. And we have to multiply that also by the g of x, 2x plus 3. Does that make sense? Is anybody struggling with why this is up there twice? It's because it's squared. So we're going to have to multiply it twice. Okay? So just start multiplying. X minus 3 times x minus 3. What's negative 3 times negative 3? 9. What's negative 3 times x? Okay, what's x times negative 3? And x times x is x squared. Add them up, you get x squared. Then what? Negative what? 6, good. Plus 9. All right, so that took care of the first two. We got to multiply now by what? The 2x plus 3, so I'll change colors. 2x plus 3. All right, 3 times 9 is 27. Good. 3 times negative 6 would be negative 18. So negative 18x. 3 times x squared is? Okay, let's move over to the 2. 2 times 9 is? Positive 18. Hey, look, those cancel out. 2 times negative 6 is? Not negative 16, negative 12. X. And 2x times x squared is? 2x cubed. Good. When you're multiplying your bases, you add your exponents. So that's a 1 plus 2 gives you 3. So 2x cubed. Was that minus 9x squared plus 27? That is your h of x. Let me scoot that up so. And yeah, I'm writing sideways. This is fine. It just slowly gets more and more tilted. It's the leaning tower of handwriting. All right, one more and we'll stop. So this, again, we're multiplying these two out. Is anybody freaking out about that a little bit? No? Good. Because remember, if we're multiplying bases, let's say I got x to the 4th times x to the 7th. I got the same base, so what do you do to the exponents? You add them. So that would be x to the what? Yeah. X to the 11th. This 4 plus 7 is 11. And your base would stay the same. If you have the same base, adding the exponents is multiplying the bases. Okay? Adding your exponents is multiplying your bases if they're the same. So here we go. Let's multiply those out. 7, 3x minus 1, plus 4, and 7, 3x minus 1, minus 4. And we'll start multiplying. So let's do the easy one first. What's negative 4 times 4? 16. Oh, my bad. Thank you. Let's change colors back, make it consistent. Thank you very much. So 4 times 4 is 16, and it's a negative 16. Negative 4 times 7 to the 3x minus 1. They're different bases, right? So you straight up can't multiply them. You just say negative 4 times 7 to the 3x minus 1. There's nothing you can do about it. Okay? So part of this is knowing when you can't do anything with it. And that's one of those times. All right? So move over to the 7. Are these the same base? No. So again, can we do anything with those? No. 4 times 7 to the 3x minus 1. All right, last one. 7 3x minus 1 times 7 3x minus 1. Are those the same base? So same base, you do what to the exponents? You add. So if I add these up, how many x's do you have? 6. So 7 to the 6x minus 2. And then combine your terms. 7 to the 6x minus 2. Does anybody see anything special with these two middle ones? They cancel out. It's the same thing, right? But one's positive, one's negative. So they go away. And you're left with a negative 16. Okay. The reason I did this one is because there's at least 2 or 3 on your homework like this, and I think every last one of them, the middle terms go away. All right? If they didn't, like let's say these were different, you would literally just write 7 to the 6x minus 2, list one of them, negative 4 times 7, 3x minus 1. Add the other one, let's say it's a 3 times 7 to the 3x minus 1. You can't do anything with them. You just have to list them out. All right? If they don't cancel, you just got to list them out. There's nothing you can do about it. And this is one of those where that is so much uglier than that. Cool. Do y'all want to do another one like B? Or we think we're good with it? Okay. We'll stop.